Just go over there, make sure everything is set up. Alright, let's get some filtering as well. Are we streaming? Yes, we have volume. Good. We go to the event. It's at 6 p.m. We're a little bit late, but here we are. Okay, great. Cool. This there. Cool. Let's check if the live stream looks good. All right. And let's go to Twitter now and say that we are live. Put a rocket in there. Conjoin. To width. Is that how it goes? I think I need to add a new tweet instead. Okay, I can do that. Oh, what's going on? Damn it. I am not well versed with tweet yet. It will take some time. But really what we want to do is add another tweet. I'm going to put it here. And then we can drop the link. Bam. Does that work? Yes. Why is this link so wrong? I do not know. But anyways, it's the right place. Maybe, yeah. It should do just fine. Okay. Cool. Well, if you're out there, welcome to another episode of Reasonable Coding. It's episode 14, and I think this will be the last episode for the year. I think I will greet you next year on the 1st with a new episode on Graphql tooling. Yes, it will be next year. So this is the last episode / stream for the year. And today we will be talking about profiling Reason Native with landmarks. And I figured that the mountain that we have here on the badge was representative of it. But if you think otherwise, please let me know. And in the future, when I refer to landmarks, maybe we can have a different icon for it. We'll be exploring how to enable profiling in a project and how to read the measured information to make sure that not only we are profiling the things that matter, but also that we understand what is the slowest part and how to make it faster. This library is pretty straightforward in what I've used it for before, so I expect it to help you, as it helped me, identify very quickly bottlenecks that are making our program slow. And to have a look at this, I think we will take a look at HTTP kit. We'll start here and see if we can run some some profiling on it to see what parts of the code are slow. Now, if you didn't know, HTTP kit is an experiment I'm running on making essentially foolproof HTTP APIs servers and clients in Reason and OCaml by using the type system as much as I can to guarantee that whatever you're putting together is sound, makes sense, is the right thing to do, TM, air quotes. So it's very high level library, but it's incredibly high performant thanks to HTTP AF, which is the HTTP backend that it's using. Right now it's tied to it, but I'm looking forward to decoupling it from it, so perhaps we can use it as a DSL for writing servers and clients that can run in Node, but I wouldn't put my money on that just yet. I think it's doable, I don't think I'm going to do it anytime soon. And this is a very fast library. One of the principles they have for building servers is that servers should be fast to run, and if you look at the time it takes for running the vanilla HTTP AF, we're clocking in about 10,890 requests per second. And when you throw the HTTP kit layer on top of that, it is 8,876, which is just 16 requests per second less. We're going to take a look at what is the bottleneck that keeps us from being about the same, maybe 1 or 2 requests per second less, and we're going to see if we can optimize that. This is an example of optimizing a project through profiling. It's not that we actually need this optimization in particular. 16 requests per second less because you have an API that's completely type safe. To me, it seems like a fairly good trade-off, but I figure that it's going to push us a little bit into understanding what really is slow. Right. Okay. So this is a repo. If you want to have a look, it's a Ostera HTTP kit, and let's get started. I'm gonna give a few minutes so people, maybe a minute or two, so people can join in. I'm gonna also share the link to the event. Events. Cool beans. So for doing profiling, there's a few tools out there that we can use. The story, it's not as nice as I was expecting it to be. Having done a little bit of profiling in other languages, I like JavaScript or the JVM. I was expecting tooling to be a little bit more straightforward. and to have a better story for working with multiple threads. But for single-threaded code, we're pretty well covered by this library called Landmarks. And of course, I should stop complaining and I should start making pull requests. So next year, I'll see what I can do when it comes to helping this library fit my use cases better. I mean, that's open source, right? But Landmark in itself, it's an incredibly simple profiling library for OCaml, right? It not only has an API that you can use, and if you use the API, of course, you can profile any code across any number of threads or machines. But it also provides a PPX that you can use to automatically enable like profiling on all of the code that you have running in a project. And there's some things around that are being worked, like for example, enabling profiling automatically by profile. And that sounds weird because it's profiling in profile. But imagine if you could do, let's go to HTTP kit. Imagine that if you could do Dune build profile debug, right? And then this automatically enables profiling information on everything that you have in your project, so then when you run your project, you can pass a flag like OCaml landmarks, and then say on, and then it's in the project, right? And then it outputs a lot of profiling information for it. That's something that's going to be worked on, not directly that, but a feature that will allow that, a capability for Dune that will allow us to work in this way in the future. But going back to landmarks, it's a very straightforward library that we can install with opam, and opam install, just making sure I have it, landmarks. Cool, we already have it, version 1.3. And we can use it with Dune in a very straightforward way as well. Wherever we have an executable or a library really, we can just pre-process it, everything with a PPX. And that's about it. That's everything that we need to do, and we'll get profiling information. So I'm using this repo because I have some tools here that are fairly small, like an echo server or a request tool. So if you go into the echo server, right, this is going to be using HTTP kit to put together. I'm going to remove some of the code that's going to be noise, really. This is going to be essentially just putting together a small server that when we call, people will respond to anything that we send it, right? So if we do Dune build, and then I'm going to just activate the auto watcher, all profile, auto promote watch. There you go. If we run this thing, build default tools echo server, then if I curl to it, port is 2112. Okay. Am I running the right thing? I don't know. I was expecting to see some log as some output. I mean, if the thing that we're trying to run doesn't work, then we are in bigger trouble than I thought. So we run the echo server, but it's never saying running on localhost. All right. Why, I wonder? And is this supposed to be port 999? Yeah, okay, so the server is running, but for some reason we're not running the onStart function, and this is just wrong. This should be 999. Okay, I'm just going to leave a to-do here. Alright, we run this. Cool. So we have our test subject, and we want to run this, and to run it we want to be able to execute it enough so that we have enough information to tell that this is indeed what's the slowest part. Why do I say that? Because if we enable profiling for this thing and we run a single curl, a single request, then maybe everything just too fast for us to measure what's the slow or the fast parts. So let's begin by enabling the measurement, and then we'll have a look at how we can make the measurements relevant. Then after that, once we get some of the data, maybe we can take a look at how we can visualize this. This is going to be a fairly short stream. I'm cooking on the side, and well, at some point I'm going to have to go cook and eat. But I'll try to cram everything in, in the next half an hour or so. So if you're listening and if you want to open your terminal and start hacking with me, then you're more than welcome. And if you did see the little tweet that we have here, turn on, and you want to retweet for reach so other people can get to see this. Sometimes it's hard to reach everyone that's interested in Reason on a camel. There are only a limited amount of channels. So let's begin by the beginning. We have the library landmarks, so we're gonna add it to the HTTP opam file, and we're gonna say landmarks. I'm gonna add it here, landmarks. I'm gonna say this should be a build time thing. We actually don't want to ship this at all. And now we want to enable it, so we go into all tools, student file, and we just say the echo server, which will depend on the library landmarks now, right? We'll also have a preprocessor enabled, and this will be a PPX, and the module name is landmarks.ppx. Cool. If we save that and it works, is it preprocessor? I forget. Preprocess. There you go. And should this be PPX? Oh, PPS. Cool. Cool. So now we can run the same thing again. And if we make a request and exit, then it will do nothing. But if we call this thing with camel landmarks equals on, I believe, then we can make some requests, right? And then when we cancel it, what? No. All right, this backfired. We're gonna need a way of closing the server from inside so that it shows the information. But before that, let me double check if this is the right way of executing the file. Huh. I'll go to the examples. Yes, the camel landmarks on. Isn't that what I typed? Oops. Yeah, that's exactly the same thing. So let's try this out with the request library, and maybe that will work. Landmarks, and then we need the PPX. So as it builds, we can build default tools request, and this tool will essentially, if I show the code, just make a request to GitHub and get my username. It doesn't do much, but I am wondering why we don't get any information afterwards. Camel landmarks on main X. Huh. Interesting. So we have the library and we're calling the preprocessor in there, but we get nothing out. I forget, maybe we do need to call zoom build with camera landmarks on. Save so it builds again. Actually, let's clean. Oh, one sec. I'm gonna make that up bigger. Oh, camera landmarks on. I am confused. I am confused because I've run this before and it has worked, and now it doesn't. But I do not understand why. Perhaps it's that I haven't changed the code at all. That was not it. Perhaps it's that LODT doesn't work as I expect it to. Oh, okay, so this is definitely not outputting any information at all other than what it already was before. And I do not know why. Camel landmarks should be on, but we should also be able to remove this and run it by default and see the output. Huh. Right, let's take a look into the issues and see if there's something we're missing. There are not many issues open. Pull requests. That's just mine. Compatibility. Huh. I am at odds here. What was it that I was doing when I was working with Cactus? See, before I was running this at some point. I mean, I don't have it built right now. At some point I was running this. And alright, I was inside of the example. So that explains the double dots there. And this library over here, right, the Cactus core, this one essentially had landmarks, and then after I was doing the preprocess with PPS, which was landmarks dot ppx. when I run it, I saw a bunch of information at the end. But I don't see it now either. How was it that I did this? Then I went to the binary and I added landmarks there. This was much easier. I remember this being very straightforward. I guess I'm getting old. My memory is not as good as it used to be. Huh. Prep process on the library's landmarks, but there was nothing that I needed to do on. Oh wait, that actually didn't do anything. Did it? No, maybe it did. The mysteries. Simply use the library landmarks and the preprocessor landmarks.ppx to benchmark your executables and libraries. For instance, the following Dune file builds executable tests using the landmarks library and its ppx. I think this is what we're doing, right? Huh. So confusing. Okay, let's see if I actually change. So I have run this several times, and if it hadn't worked, then I don't know. I can't explain why I would have run it this many times. I know that I am persistent, but I'm definitely not insane. So why would I have run this so many times if it didn't work? And if so, what has changed? To do oh, could it just be that marking it as a build dependency doesn't include it as part of the builds? No, that doesn't look like it either. Saving this thing doesn't do anything. Okay, let's just clean. Build again. running it as it is, it doesn't have anything. If I run it with landmarks on, do we get anything? No, come on. The frustration is big with this one. Request, and we have landmarks, and we have the PBX. I swear to God that it was as easy as that. Did I have to add anything else to the file? I can't quite remember. But I do know that no, I don't know that. I don't remember. Output should be the default, standard error. We're using debug, just like all the information there is. Probably should be printing with sorry, we don't really need to do that, but can't help myself. Landmarks on, landmarks off. Still nothing. I wonder if even the time of running the program is different. What? Parse error near time? Oh, right, it's a building. No. Not considerably slower, nor faster, but we don't see any output. Why? Simply use the library. Can you tell if I'm missing anything? Is there anything that's obviously missing that I can't see from here? Look at this. I don't know if it's in here that we're having a problem with something. So for example, if I add this to any of the libraries, like server tune, will I see anything? Landmarks. Such a hard time to write that word. Huh. You know what, let's take a look at the example they have and see if we can replicate that. It should be minimal. I have a Dune file. Auto. Okay. That looks like something we want to add. doesn't it? No? Is that the way? PPX landmarks. Okay, this is a different way of writing it down. I'm going to use that instead. Let's see what happens. And that doesn't exist because I think it's PPX. I got. So that should be the same thing that we have. Whoa! Sorry, PPX. Now I wonder why that doesn't work for this one's. Okay, that makes more sense. We were missing one parameter to the PPS. This should probably be documented somewhere more clearly, and we can easily just add it here. They have an example there, and even though the example is right, the result is a little misleading. So, use auto flag in flow. We just spent some time trying to figure out why the PPX didn't run, and I figured it'd be a little better to include auto by default so people don't run into this head on, this problem. Yeah. So people don't miss this flag and go about shaking their heads. Thanks for the library. I'm going to put an emoji here for like, thank you. And we're going to propose a file change. Small thing, but maybe it will help other people later. Okay, pull request. Cool. Awesome. Go back to the README. All right, so now we have our code and it's running things. So I guess that if we call the echo server, right, then this will run and we can do something like curl a few times. And by the time we exit, it doesn't really print the thing that we want. So we want to make this server, this echo server, actually close on a particular request. And I think this is going to take more time on refactoring HTTP kit than it would on making something work faster or slower. So I am considering turning this into picking a different example. Alternatively, what we can do is, since we get a promise here right after we run this thing, we could put a timer. Let's say 10 seconds, and after 10 seconds it should finish. So LWT, and I think there's racing or choose. Essentially what I'm trying to make is make a promise that in sometimes, let's say 30 seconds, it's gonna resolve, and we're gonna use a function that will take this promise and another promise, and it's gonna pick the one that ends first. So we go into the documentations of LWT. Somewhere in here we should have something that takes two promises. Let's search for TA returns. I didn't need to pick that. Syntax sure, no, unnecessary. Let's say pick. Okay, so this will this could work. In fact, we have an example right now, right here. So we could just say LWT pick, and of course we get a promise here, so the server, and we get the server there, but we also want a promise for a timeout. Unix timeout, and this would be like 10. Let's do 2 seconds to see if it runs as we expect it to run. Does it build? And it builds. So if we run this, it should exit in about 2 seconds. Nice. Okay, cool. And we already see some information that's relevant for us. We see, there's some output there at the end that we can ignore, but it would be very nice to not have in here. Essentially, we see a call graph that says there was one call that took about 6.2 gigacycles, and I think that's mostly the waiting time. But if you see here, we'll see some of our code. We'll see some of the library itself. In here, we see that on line 43, interesting. Line 43 is the one that seems to take the longest time. We'll see that line 40 of the HTTP RE file module, HTTP RE in server, line 40. Yeah, something's wonky with this. Huh. On line 74 of server, let's listen. So we see essentially the name of the function on the left, start, make, right? The file name, the module, and the line number. I'm not sure we can trust this right now. We need to take a look at why. The amount of calls that it received, and then the amount of time that it took. So if we make this thing, where is it? Echo server, take 10 seconds, then we can do something like this. We start a server and we make a request. Actually, yeah, let's say 2 seconds. We start a server and then we make a request, and then we see how long it took or what happened there. We see a request there, and then it fails, and then now we'll see that common.log took a really long time compared to the rest of the things that we have going on. This is very rudimentary, but it's already giving us an indication of where we should spend our time. If we take common log, it's essentially a whole order of magnitude slower than everything else that we're doing, right? And we see the server run now, it's taking some time as well. And because server run will execute each one of the middlewares that we have, so each one of these functions that we have here, log, inc, and JSON, then we can more or less assume that it's the logger that's taking the longest. So we can go into the logger and we'll see that here we're doing a few things. We're taking a time for Unix, we're building it into a local time object, we're extracting a few things, we're printing a string, and then we're getting the method and turning that into a string, and then we get the target and we rename it. That should be cheap. And then we log, and then we just return the state as it is. So there's a few things in here that are being slower. Worth noting that this is not necessarily slow, right? This is slower than the rest of the things. It could be that this is actually really fast, but in relation to everything else that we have here, it's obviously much slower. Also worth noting that the time that's spent doing something is not relative to the overall time it takes to run the program. It's a measurement. So if our program took 10 times as long, this would not be 10 times bigger, unless we were calling it 10 times more. But I wanna see if the problem is it's gonna be there when we make more requests than this. So let's do something else. Let's put the time to be 30 seconds, and then we're gonna run the server, but we're gonna run it in the background. I wanna see first if it if even running it in the background, it ends and shows the output nicely. Yeah, okay, we see all the output at once. It's not gonna be mixed with anything else, which means if we run it in the background, then maybe we can run a tool that does pushes a bunch of requests to the server immediately afterwards, and then we don't have to manually switch between terminals to make it run. If I search for work, then I have a command here that will run 12 threads, 400 connections over 30 seconds at a rate of 30 kilobytes per second to this address. If we change the port to be 999, then we could potentially just call this thing beforehand. And then get results back. So this is a little bit mixed right now because we told one tool to run for 2 seconds, and we told another tool to run for 30. So we're gonna do 31 seconds, so that the server runs a little longer than the benchmarking. Sorry, than the load testing. And I'm just using the load testing here to generate a lot of requests that will be sent against the server, right? So that we don't have to manually switch around. If you know better ways of doing this, please. I mean, of course, we could try to script it, and if we could do it in OCaml, then we could perhaps have a guarantee that the process, the echo server, has been launched, and then we run the other one. But if you know of any better way of doing this that's very cheap, such as running in the background and then running the other command, then please let me know. So let's run this. There should be a lot of output for each one of the requests. In about 30 seconds, if we wait for it, then we should have some relevant information about the benchmarking of the server to see what the hell is going on, what parts are slow, and also get some nice information such as the throughput of the server and so on. And that what you hear in the background is actually the rice I'm cooking, so I'll be right back. Machines are ridiculously silent machines. I ruled you. But I care about it. Okay, I'm gonna turn this off. Cool. Okay. We have results now. And as you can see, wow. Okay. I don't see the output of the other command. All right. So we run about 4,800 requests per second because the profiling actually takes a lot of resources. This is it's less than half the speed of the HTTP-AF. But we can easily see that there's a few things that we run a bunch of times, right? So we set up the server just once and so on. There's no point in optimizing these calls. Like if these ones are cheaper, it doesn't matter, we call them once. However, the ones that we're calling a lot are these ones over here. And we can quickly see which one really went off. Like on the benchmark we were doing before, when we run it for 2 seconds and then we make one request, then sure, there is a gain in taking the log down to the same level of ink, for example, to be on the same order of magnitude. But it might be the case that when you run them together, then ink ends up running so many more times that you have a bigger gain in making ink a lower magnitude, an order of magnitude lower than making log. In this case, log just grew massively, and it makes perfect sense for us to take a look into how we can optimize this one in particular to make this faster. Now, you might be wondering, why am I even wanting to do this at all? So the reason is that in the README, actually, if you go into the benchmark file, you'll see that running, oops, this should be like that, small typo. Running this HTTP-AF with LWT runs about 10,900 requests per second. And as it turns out, the way I'm building this library is to rely as much as I can on the type system and have as little runtime overhead as I can. So I've managed to get it down to 10,874, which is almost the same thing, but with the difference that when you're building the server, right, you begin a server that's empty, that's clean and has no response, right, and it will take an initial state. And then as you use middleware, you'll see that the type goes changing, and you see that this server now is actually using some middleware, and you can rely on that information for determining some things as whether the server should be started or not. And then at some point I call reply, and then you'll see that not only has middleware but also has responded. If you try to listen, if you try to start a server that will consume things but not reply, you will get a type error. Like if I remove listen from here and I save, then you'll see that this says, oh, I was expecting a server, right, that already has responded, right, but you gave me one that has no response yet. So it does a lot of things for you at the type level to let you compose safe services that are still incredibly fast, as you can see. Have a look at the README and at the principles. If you're digging that, I think they're good principles to build web services on top of. Any service really, but I would like to be challenged or iterate on them as well. So if you have any ideas or if there's something there that doesn't look quite right, just let me know. Anyways, the point is, I want to see what the hell is it that it's taking so long, and try to optimize it to see if it's a problem within the library or if it's a problem with something else. From what I can see here, right, the library itself, which is everything that begins with source, it is running as many times because for each request you have to run the middleware, and that function might not be self-explanatory in the name, but it's defined here. If I call it that, then it will be much obvious. Run middleware stack. Here you go. So this run middleware stack function, right? It's running for 52.92 cycles, gigacycles. And I mean, if we do some basic arithmetic, and I don't think this is the right way of doing this, but if we do some basic arithmetic, we might find out how much cycles it actually is taking. We know that the logs is taking 59.97, and then we also know that another function, the ink one, sorry, the JSON one is taking 1.91, and that leaves us with 1.04, which if we remove the 0.6732, leaves us with 0.27 gigaseconds. So it's about 27 M. But actually, I'm not very comfortable with this way of measuring how much this function is really taking. And if we want to optimize the framework, then it makes no sense to optimize the log function that's part of the example. So let's do something, and let's disable the benchmarking for the actual examples, right? Let's just say you over here, I'm just going to roll back the changes. Here you go, 1, 2, 3, 4, 5, boom. And we're still going to be running this server, the example server, right? Where is it? I lost it. For some time, for about 31 seconds. I'm going to put 35 because the tool that throws requests at the server is taking a little longer, and it's not finishing. Actually, it was finishing well. It's just finishing in a weird order. Yeah. Anyway, I'll just run this again. Let's rebuild, and now we should see only the part that we want to optimize being profiled. So we narrow down on what's the parts that are relevant for us to work with. We're going to do the same exercise we did with the log function, right? That we're going to run a lot of things to see how it scales up. And then we're going to see how we can make it better. And of course, there's something that it's already using that port. And I wonder why. So I'm going to do a pickhill echo server. We already had a server running that. And I know why. We should probably kill the server after the benchmarking tool has finished. Again, there's absolutely better ways of doing this. This is just the hackiest one that I could come up with right now that will still give us the results we want. So let's run it. 30 seconds, and in the meantime, I'm gonna go check if the chicken I'm gonna be cooking is defrosting. It needs a minute. It needs another minute. All right, it finished. Did we see the results or transfers 5,000 sec? Huh, it didn't work. Okay, I'm gonna remove the pickhill. Maybe we kill the server before we too fast. Okay, now we can do that. What? But I just killed it. Okay. Huh. Interesting. What happens if I run it but without the tool? The address is already in use. Nope, that's not what I wanted. Okay, so now something finished. I don't have any background jobs. Do we have any server running? No, we don't. I forget if it's P, report. Ooh. Echo server. Nope, okay. I don't remember how to use LSO. If we run this thing, it should at some point finish the server on the top level terminal. Cool. And then this one we can quit. That's fine. Alright. So now we see the data there. We see that we called run middleware stack. I renamed it so that it was more obvious. And this one ran 85,000 times. And really this is the most expensive function that we have. Everything else that we have here, like listen or start, takes a few thousand cycles, a few kilocycles. But this one over here is taking 32 million out of the 96. Which of course, you have all the profiling in there and so on. So this is really the thing that's adding up. And it's about a third of the whole program execution, considering the profiling. I don't have a good way of saying, oh, when you don't profile, this actually goes this much faster or this much slower. But I'm thinking that we can take a look at the implementation and see what can we do to optimize it. There might be something that we can do. Maybe there isn't. So we go into the server and we see line 38. We see the function. And this function might look a little weird to you. It's essentially a polymorphic recursive function over a generalized algebraic data type that allows us to build a function over, it's essentially a heterogeneous list where here's the type that it uses. It's called stack. The end or the empty list is called init, and it has a single element. But every next element will be a middleware that goes from some type B to some type C, and it will take a stack that begins with an A and comes out with a B, so that we can compose this later and we can say, if you give me an A, then I have a C, a B, right? And because you just gave me a function that goes from B to C, now I have a function that goes from A to C. Another way of seeing this will be if you call this in or out, right? You could call this return, stack, like that, and then this will be compose. And you get some F from B to C, and then you get a function that goes from A to B, right? And if you call compose with a function from B to C, and you had a function from A to B, now you get a function from A to C. This sounds weird. It's because we're lifting the type information one degree up so that we can build middlewares that are safe. And here we're essentially building a record again, right? After we call the rest of the middleware stack. Eventually, this middleware stack will return last, and once it returns the last, then it will be able to. Then it will be applying all these functions together. So I'm wondering if maybe we want to do something different here instead of this recursive polymorphic function. I'm not entirely sure how we can do this in other ways, given that the type information is. I mean, we have to tell the compiler there will be a type I and a type O such that this holds. If we don't, like you would normally do in your other functions, like, where is it? Where do I have any functions? I can't see anything. I'm blind. Like here in middleware, in reply, where you see that there will be some B, but this is a variable really, right? In here you have to guarantee the compiler that there will be a variable, type variable I and O, instead of using a type variable like this with apostrophe. So we don't have a lot of information to work with this. What part of this is slow, and why is it slow? Is it the recursion that's slow? Is it building the records? I wonder if f, right, was a function that had a different shape, such as you take a context, right, and then you get an A as a second parameter, and then you return a B. I wonder if that would make things different. So for example, if we do that little bit of a refactoring here, there will be no more state in the context. The context is just a response, a function, and a request. And then if we change the examples, I think only the examples. Let me expand the errors over here. Yes, server line 19. We need to. Okay, I'm gonna declare brand group C in Vim. I'm gonna have to change some of the signatures here. And there will be no more state there. Now you get a context, and also you get an A, right? Which means now our servers will fail. Echo server line 12. This should be a function from a server context and some A to an A. It would save. Then now line 22 says that it has no idea what the state is, and that makes sense because it should be a different variable, state, right? Same for all of this. It should be state, and then we're just going to call state there. We probably need to ignore the context. State, context response, perfect. Cool, line 75, we're almost there. Now the context doesn't have a state, so we just have the context once, right? And then we can have let state equals initial state. We don't even need to do that there. We just need to call these functions with context and then the state at the end, which means we can point free them. Yay! If you apply everything with the same context, then the state will be threaded through. But of course you need the app initial state here. There you go. And now the echo server, it's changing. We're almost there. Line 12, we need to do the same changes, so I'm just going to copy the middleware, which is exactly the same in both examples. Saving the module. And now line 18 of the server has some changes to be done. We can do those. Line 18 of the server RE. And that says that the type declarations don't match, which I think makes sense because the module type is M, but we should remove this. We don't need this anymore. The module type is in the interface. Cool, so line 28 now says that there's a problem, and that makes sense. Why? Why does that make sense? It makes sense because now we're getting to the point where we had our function run middleware stack, and we need to do a little bit of refactoring there, which is good. So now instead of giving it f with all with this one object, we will call it first with the context, right? And then we will call this thing with the return of the rest, which means I think we can call it this way. I hope. Cool. So same deal. We can run this and we can see if it's slower or faster, and then we iterate. If it's faster, then we continue in this direction. If it's slower, then we go back and re-evaluate. Running. Something that's very important to understand here, and that I don't entirely understand, is the memory model, right? So when you have a GADT, what's going to happen with each one of the elements, or let's say, yeah, which one of the values, and how are they going to be boxed and represented at runtime? I am not too savvy about that. I think it's something I would like to learn a lot more in the future. That's why there is Stream in particular. If we go to events, there's one into the future that I'm really looking forward to, which is understanding the recent native garbage collector, which will force us to explore really, okay, so how can you free up the memory, and how do you allocate it and keep track of it? And to understand that, we need to understand a little bit as well of how the memory is represented. And it just makes sense that tied to that information is what memory representation different values have. I know that the Real World of Camel book, dev.Real World of Camel, the old one and the new one as well, I mean the rewrite, is it a rewrite? Has memory representation of values here that we can have a look. If we open this, it explains why the types disappear in runtime, block and values, distinguishing integers and pointers at runtime. So adding things to values that records extra metadata is called boxing. Not all values have to be boxed runtime. So I don't know if this is going to make any reference to GATs. Okay, polymorphic variants, tuple, records, arrays. Interesting. Tuple, records, arrays, variants, lists. I don't entirely know. It's something that I should probably sit down and read. And yes, this next chapter is going to be the basis of that live stream. Going back here, let's see how we did. So this, I think this is slower. I'm going to copy these results. I'm going to start pasting them somewhere. I don't have a lot of time left, but with the time that I do have, oops, sorry. So the aggregated table, and then we're going to copy the old one, which should be above, somewhere up here. Not too far up. Maybe, yeah, I'm just going to search for aggregated table. And this is the first one. Huh, is this the only one? Yeah, okay, we had so much logs that it got lost. Damn it. I was not counting on that. Okay, but we do have some code there, which means if we reverse this change, oh wait, that's too much. It's there. We can also change this interface back. And we can change the examples back. Cool. And so it runs. Oh, sorry. I think I'm just speaking low. I should probably speak up a little bit more. Thanks for the follow, by the way. Hope you're enjoying the content. Cool. So this was the new code. I mean the old code, and this one in not that much faster than the new one, I believe. If we go into our file, we'll see that we have 53, 35 in the new one, and 53, 54 in the old one. Okay, that's a very tiny gain, really. I mean, we're still in the same order, 140,000 calls. It's a very tiny gain, it's not massive. So perhaps to make this even faster, we would have to restructure the code considerably. It would be worth taking a look at, for example, keeping a stack, keeping the context outside of the middleware stack. So essentially, when you run the middleware stack, what you get back is a single function that's composed, and then you just thread the context through all of that. But I would like to sit down and do a memory representation of what is going on here to better understand what is it that we need to optimize away. For what it's worth, taking a look at the benchmarks that I was doing very informally with the rest of the other languages and platforms, the only one that seems to be on par with this, it's Go. But of course, Go has all the type problems that it has compared to the features and, let's say, the sophisticated type system that a Camel has. So 3,000 RPS more. I don't know. It's a bunch, but it's not 2-3 times, right? I was expecting it to be perhaps even faster. It did have a lot of throughput more, which I'm curious about. I'm still learning to use the work2 tool for it. But yes. Okay, so this has been a little bit of profiling with landmarks. You can take a look at essentially an aggregated table of each of the calls and how many times they're being called and the time that it has. We've started with the profiling of the full server, and then we've narrowed down, okay, we want to work on optimizing the library it builds upon, so we've disabled things that we didn't want to see, and we started narrowing down, and we found a way of running enough requests through the server, of essentially of heating it up, warming it up enough so that we can tell what is representative and what is just noise, or at what scale do we actually run into these bottlenecks. And after identifying that the running of the middleware stack essentially is the slowest part that we have right now, we've tried to optimize it. And after we changed the representation of it, we refactored and we ran the whole thing again, and then we informally compared what the differences were. And we saw that even though there was a performance gain, it was not substantial. It could also be argued that the little difference that we have here, this 6,000 or so requests, could have caused the difference. So maybe this is just not conclusive. So perhaps it is the architecture that we have for running this middleware stack that is a problem, and we may want to reconsider it entirely, right? Yeah. Yes, precisely. Okay. I hope you had fun with this. I hope you learned something. I know that I learned, at the very least, that we need to pass the auto flag into the library PPX so that it works automatically. And I'm starting to reconsider how to actually build this. I haven't found other ways than using GADTs, and thanks ContainerQ for helping me figure that out. To build this this function type safely to provide safe middleware. It still is fairly fast, but I'm wondering if I can get almost the exact same runtime performance as HTTP-AF without any of HTTP-KIT, right? That's pretty a little bit weirdly phrased. I wonder if I can reduce the overhead of using HTTP-KIT so that it's almost the same, like virtually the same thing as using HTTP-AF, which to me would mean there's really no good reason to use it directly when you can have this very strongly typed layer on top. But that's for a different live stream. Anyways, I hope you have a really good year next year. Happy New Year and all that, whatever you believe in. I'm gonna go cook some chicken with rice, and I just remembered that I forgot to put the saffron in the rice, so it's not gonna be yellow, it's gonna be white. But anyways, yeah. If you like this stream, please leave a follow. Amazing, awesome. Please leave a follow and take a look at the other events that are going to be coming up in the beginnings of next year, Jan 1, and then we're going to be talking about the LWT and look how it works from the inside out. Essentially just digging through the source, trying to make sense of it, hopefully writing something about it. Then we'll be exploring recent native, and for a change of pace, I would like to take a look at building a GraphQL API in Airlink. I have done Airlink programming professionally before, but it's been a while, and I want to see what it feels like to build something in a strongly but dynamically typed language like Airlink, compared to the static and strong one like Reason or Camel. And there will be more events, so if you subscribe, then you will get more, what do you call this? More content in the long run. Yes, that's about it. Have a look at Landmarks, start it. It's a pretty good library. Try to use it if you can. It works perfectly well for native development, both for Camel and Reason. There isn't really code for this particular stream. If you're interested, HTTP-KIT lives here. You can have a look, leave a star, read through the principles, and just argue with me why they're wrong and how we can make them better. Ideally, we can make a library that works for different backends as well. So maybe you can use the same API and just flip a switch, and boom, it works for Node, and you get for the JavaScript runtime, and then you get these really performant servers also that are safe for Node as well. And if you want to follow, there's a thread on Twitter that essentially just screams when I'm live. And if you want to retweet some of this as they come along, they will help me get some more people to take a look at what we're doing. There's not a lot of resources for Reason, and I think it's a good idea to show people that even though to show people that you just don't know something and have them learn with you as you do it. Anyways, thanks a lot. Thanks for this year, and stay reasonable. Take care.